Hey guys, today we're talking about rational exponents and properties of radicals. Furthermore, we're just talking about like things that you've seen before, which is a little bit extra added on. Okay, so we're going to try to go through this as quickly as possible. It's kind of a longer lesson, and it seems tough at first, but you can get it. Okay, so let's start here. Over here on the side, let's remind us where we came from. So remember, we can start off with like multiply. Whenever we multiply, we're going to multiply my whole numbers together. 4 times 3 is 12. X to the 4th times x squared is x to the 6th. Because remember, whenever we multiply exponents, whenever we multiply their bases, we add the exponents. So this is going to be 4 plus 2. The opposite is true here. Whenever we divide, 6 divided by 2 is 3. X to the 5th divided by x squared is x to the 3rd. And so it simplifies like that too, okay? Now, the only thing that's different with what we're doing today is you'll notice here that we have these fractions. Well, don't let those freak you out. They're just the same basic idea. We can just add and subtract fractions just like normal. Remember what we did in 6th grade where we had to find common denominators to add and subtract fractions? We're doing the same thing here. Look, we're going to multiply here at number 1. 2 times 3 is 6. X to the 1/4 times x to the 1/2. Well, we're going to add those two together. We're going to go 1/4 plus 1/2. And remember, to add, we need a common denominator. So we're going to go 1/4, and we're going to change that 1/2 into a 2/4. If you don't remember how to do this, you can use your calculator to help you add these together. But just 1/4 plus 2/4 is 3/4. That's going to be 6x to the 3/4, okay? So that's all we're doing. Multiply your whole numbers, add your exponents. Whenever we divide, we're going to subtract those. So take a look here. We have -4 divided by 6. That doesn't divide evenly, but it can reduce, just like a fraction. So it's going to be -2 over 3 is what that reduces to. And then x divided by x to the 1/3. This x right here, there's an invisible 1, right? So it's going to be x to the 1 minus 1/3. So we can kind of go off to the side and go 1 minus 1/3. And we can take that 1 and make it a 3/3. So we go 3/3 minus 1/3 equals 2/3. So that's going to be on top. We're going to have an x to the 2/3 on top there. So here's my answer. -2 times x to the 2/3 over 3. Okay. So look here at number 3. So number 3, we got a lot going on. We have my whole numbers, we have my x's, my y's, my z's. Let's start with my whole numbers. 14 divided by 2. It's going to be 7. What about my x's? Well, my x's, I'm going to have x to the 1 divided by x to the 3/4. And remember, when we divide those, we're going to subtract the exponents. So on this one, I'm going to go 1 minus 3/4. We're going to change that 1 to be 4/4. We're going to go 4/4 minus 3/4 is not just 1, it's going to be 1/4. So we're going to have x to the 1/4. Next, my y to the 1/3. There's no y on the bottom. That's not going to change at all. So we're just going to keep that as y to the 1/3. And then our last thing here, this z to the -6. That z to the -6, remember, if you have a negative exponent, we have to flip it. So we're going to take this z to the -6 and just bring it to the top and make it a z to the +6. That leaves nothing left on the bottom, right? So all of this is just over 1. So that's just going to be my answer. If those colors bother you, we can just rewrite it all with one color, 7x to the 1/4, y to the 1/3, z to the 6th, and that's our answer. Take a look here with me, please, at number 4 now. And notice how on number 4, we start off with a negative exponent. So if you have a negative exponent, be thinking that we're going to flip something, right? And so whenever I see this negative exponent, I'm going to flip this entire fraction. So I'm going to flip this fraction to be 2 on top, x to the 5th, y to the 5th on bottom, times that -1/5 is going to change to a +1/5. Then we're going to distribute our 1/5 here. We're going to go 2 to the 1/5. We can just rewrite that, 2 to the 1/5. And then x to the fifth to the 1/5. Remember, we multiply my exponents here. And 5 times 1/5 is 5 over 5, which is 1. So we're going to have x to the 1 and y to the 1 after we distribute that in. Okay, I can leave it like this, or we can rewrite it as the fifth root of 2 over xy. But like I said, you can leave it like this. That is not against the rules, okay? You can leave it 2 to the 1/5. I just wanted to remind you a little bit of what we did yesterday and rewrite that. All right, let's turn the page. Okay, so we talked about what happens whenever I have fraction exponents. Now let's break it down with caking. So we're going to be caking these, and we're going to be caking each of these individually. So take a look at number 5 with me, please. So number 5, we have the fifth root of 4, a to the 8th, b to the 14th, c to the 5th. And we're going to be changing each one of these. We're going to be simplifying each one. The first thing that you need to do whenever you cake, whenever you simplify, is you want to look at the index. And in this case, my index is that 5 right there. So to cake, we're going to have to be circling in groups of 5. So let's start with my whole number, that 4. If I cake that 4, it's just 2 times 2. It doesn't cake at all, right? I don't have enough to make a group of 5. So we're going to come over here, we're going to write on the outside, on the inside. And that 4 is going to stay on the inside because there's not enough to cake it. Now let's do my A's. We have 8 A's, so I'm going to write that here. We're going to go 1, 2, 3, 4, 5, 6, 7, 8. 8 A's. And we're going to be circling in groups of 5. So there is a group of 5 A's. So we can bring one A to the outside. It takes a group of whatever your index is to bring one number to the outside. So we're going to bring an A to the outside, but we're going to have 3 A's left over. So I'm going to have an A cubed is going to stay on the inside. Now let's do my B's. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we're going to draw out 14 B's. And remember, we're circling in groups of 5. So here I have a group of 5. Here I have a group of 5. And so we have 2 groups of 5 that I can bring to the outside. So we're going to bring a B squared to the outside because we have 2 multiplied together on the outside. And I have 1, 2, 3, 4 B's left on the inside. So we're going to have B to the 4th left over on the inside. Last one, our C's. So we have 5, 1, 2, 3, 4, 5 C's. We can group those together, right? And so we're going to have just one group of C's that we read outside, and that doesn't leave anything left on the inside. So let's write out our equation. Start with our outside. On the outside, I have A, not A squared, just A by itself. We have A, B squared, C times the 5th root of 4A cubed, B to the 4th. And that is it simplified. Okay? The same ideas apply to number 6. So this time, my index is 3. And so we're going to start with our x to the 14. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we have 14 x's. And we're going to be working with these in groups of 3, right? Because my index is 3. So here's a group of 3. We have 1, 2, 3, 4 groups of 3. So on the outside, I'm going to have x to the 4th. I have 2 x's left over, so on the inside, we're going to have x squared. So I have 4 x's on the outside because we have 4 groups of 3. Now what about my y's? Well, with my y's, I have, this is a negative. Well, that negative is just going to follow my numbers around, okay? So that negative, we're going to go y to the negative 1. We have 6 y's to the negative 1, right? 6 y's to the negative 1. We're going to circle those y's in groups of 3. And I have 2 perfect groups of 3. So we're going to write that out here as on the outside y to the negative 2. Okay? So on the outside, that's what we have on the outside. And remember, it just stays negative. We got the same numbers. It's just going to be negative. So now I can write that out over here. We can go on the outside, we can have x to the 4th, y to the negative 2 times the cube root of, left over on the inside is just x squared. However, my last and final step, we don't want to leave this as a negative, so we need to bring that to the bottom, right? So we're going to just rewrite it with x to the 4th. Rewrite this as x to the 4th times the cubed root of x squared over y to the positive 2. We want to take that negative exponent and move it to the bottom, and that's the end there. Okay, let's try number 7 and number 8. Sometimes we don't simplify first, we have to multiply first and then simplify. So take a look at number 7 with me. We're going to start off by multiplying these two together, then we're going to simplify. So I'm going to start off by going 12 times 18. So I'm going to pull out my calculator, and 12 times 18 is 216. So we're going to have the cubed root of 216 times x squared times x is x cubed. All right? So we have 216x cubed. Now I'm just going to simplify that by caking it and whatnot. So we're going to take that 216, we're going to cake it. 216 divided by 2 is 108. 108 divided by 2 is 54. 54 divided by 2 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. So you can see here that we have two groups of 3. I have a group of 3 3s, a group of 3 2s. So both those can be on the outside. And then check out my x cubed over here. My x cubed, we have 1, 2, 3 x's. That's a perfect group of 3 as well. So we're going to have 3 times 2x, nothing left on the inside, so it's just going to be 6x. You can write the out and in if you want to, if that helps you. If not, though, if you just want to get to it right away and you're confident in your abilities, you just write it like this. Say, look here at number 8. Number 8, we're going to start off, instead of multiplying our insides together, we have the same type of root. We have a 4th root on top, a 4th root on bottom, so we can divide. So I can go 160x to the 6 divided by 5, and 160 divided by 5 is 32. So this is going to be equal to the 4th root of 32x to the 6th. And we can cake 32, and we can cake x to the 6th. So we're going to take that 32, and I'm going to cake it. I'm going to go 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. We're going to have a group of 4 2's that I can bring to the outside. So on the inside, actually we're going to write the outside first. So on the outside, we're going to have 1, 2 brought to the outside. On the inside, we're going to have 1, 2 left over. Now what about my x's? We can take 1, 2, 3, 4, 5, 6 x's, and we're circling in groups of 4. So we're going to, that's 5 that I circled. Goodness. We're going to circle in groups of 4, so we're going to circle one group of x that we can bring to the outside. So on the outside, we have one group of x. On the inside, we're going to be left with x squared, okay? Because we have 2 left over. So write my answer out here. We have 2x on the outside times the 4th root of 2x squared on the inside. So that's all there really is to caking. Just think about each variable and each number. Sometimes you have to multiply before you can cake. Sometimes you divide first. Okay, let's turn the page, and now let's talk about adding and subtracting. The big deal about adding and subtracting is you have to be counting the exact same thing to be able to add and subtract. So we can go ahead and do that on number 9. Look at this. I have 4th roots of 10 and 7 4th roots of 10. So if I have 1 4th root of 10 and I have 7 4th roots of 10, we can add these together, and that makes 8 4th roots of 10 once we add those together. The same idea is true for 10, but sometimes we have to simplify first before I can actually add things together. So this third root of 54, I'm going to cake that 54 first. So 54 divided by 2 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. And you can see that we can bring a 3 to the outside here and leave in a cubed root of 2. And so now, all it is 3 cubed roots of 2 minus, remember there's an invisible 1 right there, minus 1 cubed roots of 2. It's going to be 2 cubed roots of 2 as my answer. So sometimes you have to simplify it first and then add and subtract, okay? So on this one, we're going to add these two together because they're counting the same thing, but can't add this one, the one on the end, the square root of x, to anything. So we're going to add these two together first. 5 square roots of y plus 6 square roots of y is 11 square roots of y minus the square root of x. That one's just left off by itself because I can't combine it with anything. We're going to skip number 12. If you want to get the deets on number 12, go look in Canvas at the notes there, okay? All right, let's move on to number 13. Number 13 is kind of the same thing. We have two separate things. I can simplify both of them individually, okay? So we can simplify them both individually and then combine like terms. So I can go, the square root of 9 is 3. The square root of w to the 5th, we can work that out. We have 1, 2, 3, 4, 5 w's. We're circling in groups of 2 because there's an invisible 2 right there. And so we're going to bring 2 w's to the outside. So we'll have a w squared to the outside times the square root of what's left over, 1w. Same thing over here. We can take these w's, 1, 2, 3 w's on the inside, bring a w to the outside. I already have a w out there, so that's going to be w squared. We have a w left over. So now we're just adding and subtracting because these are the same. So we're just going to go 3 minus 1 is 2. So we're going to have 2w squared square roots of w. For our last two here, all we're doing is multiplying. Now this is something you've seen before. We did this last semester. All we have to do here is distribute. So like for this one, we're going to distribute this square root. So we're going to go the square root of 5x times the square root of x is going to be the square root of, we can multiply what's inside. So we're going to go 5x times x is 5x squared minus square root of 5x times 5 square roots of 5 is going to be, well, our 5 is right here is just going to stay on the outside. And the square root of 5x times 5 is going to be 25x. All right. Then we can simplify each one of these individually. I can simplify this one by saying the square root of x squared is x. We can move that to the outside, and then I can't cake or do anything with 5, so it just stays there. I can change this 25, the square root of 25 is 5, so I can bring that 5 outside. I already have a 5 out here, and we can just end up multiplying those together. So we're going to have x square roots of 5 minus 5 times 5 is 25. 25 square roots of x. Now, these two can't combine because I'm counting different things. So that's just my answer. We simplified as much as we could, and sometimes that's all you can do. Our last problem here, you'll notice we have this squared. And whenever we square something, that means we're taking that thing and multiplying it by itself, right? So to simplify this, I'm going to take this 4 minus the square roots of 5x times 4 minus the square roots of 5x. And we're going to distribute. Remember, this is our FOIL. We're going to do first, outer, inner, last. Okay, so we're going to go first. 4 times 4 is 16. Outer, 4 times negative square roots of 5 is negative 4 square roots of 5x. Inner, negative square roots of 5x times 4 is also minus 4 square roots of 5x. And then our last two, square root of 5x times a negative square roots of 5x is going to be a positive square roots of 25x squared. Okay, so now let's simplify this a little bit. First off, these two are like terms. So I can add these together because we're counting the same thing. So we have a -4 and a -4. That's going to make a -8. Square roots of 5x. And then this can simplify. The square root of 25x squared is 5x squared. Because look, 25 concave to be 5 and 5. So we have a pair there. And we have two x's on the inside here. So both of these can be simplified. My apologies, that's not an x squared. That should just be an x. And then we have this 16 here at the front. And then that's it. We can't combine anything. So that's my final answer. All right, guys, I hope this video has been helpful to you. And I hope you have a great rest of your day. As always, please, I know this lesson was tough. Let me know if you have any questions. Thanks, guys.